Okay everyone, I'm going to show you an alternative to Insteon. Now, if you're familiar with Insteon, perhaps your friend has it, you know what that's about. I mean, if you have a friend that has Insteon, basically when you go to their house, typically, you walk in and the house is typically dark. And you go to your friend, can I turn on the light switch? And they'll be like, no, don't touch the switch, look what I've got. And they'll pull out their iPod, and they'll be like, oh wait a minute, I gotta log in, hold on a second, okay, I got a Wi-Fi connection, and then they'll be like, okay, I'm logging on to Insteon, okay, wait a minute, let me find it, hold on, and then they'll be like, blip, and the light goes on. And they'll be like, isn't that the greatest thing ever? And you're like, you look at them, and you're like, I don't know how I live without this Insteon thing. Well, let me tell you. There are alternatives to Insteon, and it's something you can make for yourself, and it's something you can do cheaper than just buying Insteon. Now, there are some negatives of Insteon, and let's talk about that. First of all, it can be very expensive. I mean, in my basement, I have 4 switches, basically 4 switches turning on the hi-hats in the basement. They're controlled by 2 circuit breakers on the circuit breaker panel. So even to replace 4, it would cost you between $180 and $200 just for one room. I mean, you can easily spend thousands of dollars on an Insteon system doing your whole house. And that does, you have all the controllers that you need, the modules, the each switch, outlets you'd have to replace. It's also pretty time consuming replacing all of those outlets and switches. And then Insteon changes the technology, they'll come with a better technology, you'll have to update again. You can easily spend thousands of dollars. The other thing I noticed is that the Insteon switches, I have questions about their quality. I mean, personally looking at them, they're very light. Friends have reported to me that they break down a lot, that they have to be replaced every few years. I mean, that can be expensive. Also, if you look at the wiring on the Insteon switch, basically they use aluminum wires. And the real question is, what's up with this aluminum wiring? Why can't they use copper? Let me see if I can get some more light in here. I don't know why they just don't use copper wiring. It's silly. They're just trying to save $1 or $2 on each unit. And I've read something about not mixing copper and aluminum wire. It's not a good idea. So let me show you an alternative. I'm Jacob Silver, and this is my system. I call it the Silver House Intelligent Timer System, and you can make this yourself. Basically, what I've done is, I'll give you an overview and then I'll try to zoom in for you. If you've ever installed a transfer switch for a generator, a manual transfer switch like one made by Reliance, basically you'll be familiar with this process, and it's something that I've learned by doing that. I mean, it's safe to touch this part, but I'm going to be using a stick because I'm going to be showing you the details of the wiring, and it's always a good safety precaution. What I'm basically going to be doing is this. I'm using these 3 timers along with a set of relays, which extend the number of circuits I can control with timers. And basically, instead of using the Insteon system to control when lights go off, when lights go on, I basically used a couple of good Intermatic timers, which are really excellent, highly programmable, and the system really allows me to control much of my house. Basically, some lights go on and off daylight saving according to sunset and sunrise. Others go off Friday night and turn on Saturday morning. So we'll go through it and I'll show you it. First of all, this is the Intermatic timer system. I'll try to zoom in on it for you to show you how it is. I have 3 timers. This is a Intermatic 1105C. It's ET1105C. That's the model number. That's that'll control 1 circuit. This one is the ET1725C. That controls 2 circuits. This is the ET8415CR, and that controls 4 circuits. Now, just to give you a sense, first of all, the timers and how they work. I'll try to zoom in on it for you. as you can see, this one is the ET1105C. Basically, you have this one, these are the power for the actual timer. And this is a circuit. It's basically just a circuit that either opens or closes. And you have over here, it's fully programmable. It keeps track of the date, the time, and you then program each function either on or off, when it should go on, when it should go off. When it goes on, it basically just closes the circuit. That's all it is. It's just closing this circuit. Again, this is the power to the timer, and this is the circuit that it controls. Here is the battery. It keeps a battery. The battery is good for 3 years, it says. And it's relatively simple. What's good about this model is it automatically updates for daylight savings time. And it's very simple to program. The clock keeps very good time, and it's pretty easy to do. And you can see there's like if you can catch it, there's an indentation here. It's not cut out, but on other models it is cut out. This is the ET1725C, and this one is the same thing. This is the power to the unit, and here are two circuits that it controls. Here there are more buttons on it to control. You can program the events, and you can program each of these two circuits. In other words, you choose. In other words, it's going to go on. Let's say at 9 o'clock in the morning, go off at 11 o'clock at night, and you can then say load 1 should go on and off at that time, or load 2 should go on and off at that time. Basically, this also keeps track of daylight savings time, which is helpful. It has batteries, 2 circuits, and we'll go through the wiring in this. This one's a little different. This one is really fantastic. This is the ET8415CR. It has 4 different circuits. It's a little different. You see here on this one, you just run the wiring through from the bottom up that green bar, and then you tighten it with a screw. With the other ones, you were basically running the wire around it and running right around this, and then tightening it on tightening the screw down on the wire, which was like a U. With this one, it's easier. You're feeding it through, and it's just connecting. The timer is connecting these two. So this is a 4-circuit timer, and this is really Intermatic's top of the line of this level of timer. After this, it becomes much more expensive. This one keeps track of daylight savings time. Is programmable. It has about 30 or 40 events. You can really program this to your heart's content. Also, what it does is it also has a mode of programming it keeps track of sunrise and sunset. So you can say, for instance, turn on at sunset, shut off at sunrise. You can say turn it off, or you can say turn it on, for instance, 2 hours before sunset, and then turn it off an hour after sunrise. I mean, it's really a computer, this one. The other benefit is, if you notice, there's no batteries in here. This model has a supercapacitor. It keeps track of the memory for 100 hours after it loses power, so you don't have to worry about changing batteries. I mean, I don't think that's a big issue, because the batteries, they say, last 3 hours in the other timers. But this one, batteries aren't an issue. Daylight savings time is not an issue. You really can program a lot through this. So basically, and what we'll do is we'll start with for the first one. This controls the warming drawer, and basically we keep it on. We keep this program so that the warming drawer shuts off at night. Why? If you're Sabbath observant, there are times you may not be there to shut off something. This makes sure it's shut off. We have this programmed so that every night it just shuts off. This way, if we leave it on, it'll shut off, and then it'll turn itself on automatically the next day. So how do we do it? Well, we have this circuit over here. Like I said, this is just providing power to the timer itself to run the circuitry. This over here is the actual circuit. It's either going to be opened or closed. So you program it. When you want it on, it'll close the circuit. That's all it does, close the circuit. And when you want it off, it breaks the circuit. So what I did was, I took it off the circuit breaker, and what I did was this. You take a circuit that controls the warming drawer. I'm trying to find it offhand. Here's the warming drawer. And what you do is this. Typically, on any circuit, you have three wires. You have the hot, the neutral, and the ground. The neutral and the ground are up here on these things, and they're mounted over here. This one, and on the circuit board on the other side, you have your hot and your ground. Those are on the circuit. Those are always connected. What this circuit breaker does is when you turn it on or off, it's sending power from the back of the circuit board, which is hot, from the back through the switch, and it goes through this black wire, and it goes up, to let's say in this house, the warming drawer. Could go to another wire will go to your lights. Each one of these switches controls part of your house. So what you do is you take a piece of wire. I use 12-2 with the ground, which is standard 12 gauge wire. What you do is you take the piece that's long enough to reach your timer from the circuit breaker to the timer, and you can pull out the ground, because you don't need the ground. The circuit will already be grounded here. So what you do is you pull out this copper from that piece of wire that's going to go from the circuit breaker to the timer, and then you take the two wires and you bring it through here and into this box. And what you do is you take out the black wire that goes up into your house. You take that out. And what you do is you connect one of these two wires. It's either the black or the white. It doesn't matter. One into the circuit breaker, and the other one you connect to that wire that you removed from the circuit breaker that goes up. So basically, what you've done is you've disconnected this wire and then connected a new wire one into there and one to that wire that goes up that you pulled out, and the circuit then is basically extended from this wire to over here, so that whenever these two wires are touched together, it's basically sending the power. It's taking a detour. Instead of the power going straight up from the circuit box, it's going across into this switch, coming across here, back out, back into the box, and up. It's very simple. It's the same principle that transfer switches use when you have a generator. And it doesn't matter that the wires the wire is black and white, the colors, just ignore the colors. Just take out the wire that goes from the circuit you want to control, and then take the new yellow wire, put it through, put one wire in here and one connect to that wire. What you also want to do is you want to label everything. Each of these things that I've done, I've labeled. Kitchen lines 1, kitchen lines 2. Here there are 4 switches in the kitchen, and it's running off 2 circuits. You want to label everything. One is you figure if you're not around, someone can figure it out. If you sell your house, you want the new owners to figure out how to do it. Also, I always figure if I drop dead, I don't want my wife to have to sell the house, because she'll be totally lost as to what I've done here with this system. But okay, so that's this one. Now we'll get to that one. This one is the one I have programmed. The outdoor front lights is circuit number 1. The living room, and it's also connected to the attic bedroom. That's circuit number 2. 3 is the dining room, and 4 is the hot water thermostat. And basically, what I've done is, for most of these, I've just done the same thing. Run it from here, just taken a wire, run it from here, in here, disconnected the wire, attached them there, and then run it into here. Now, what's nice about this is I have an outdoor light, the front light, and that's programmed to turn on every night at sunset, and then it turns on again every morning at it turns on at sunset and shuts off at sunrise. Then I have here some of the other lights: the living room, the dining rooms. They turn on and off at different times. Friday night they're on Friday. They shut off Friday night and they go on again Saturday morning. Now here's an interesting one: the hot water thermostat. Basically, what I've done is, and I'll show you more of it. But basically, I've intercepted the 24-volt wire that comes from the hot water tank, the thermostat, and I've run it through number 4. And what that basically did is, I'm shutting off the hot water when we don't need it. In other words, we usually shower at night, so after midnight until 4 o'clock the afternoon, when we come back home often, it shuts off the hot water. And we can always override it. Just you come in, whenever you're in, you can always just hit one of these buttons and you can manually override it. But what that does is, this way you don't have to have the hot water tank heating up hot water all the time. When you're not around, it just shuts off the hot water. And I'll show you how that works. In the meantime, I also have a second way of intercepting the hot water. I have this switch, which is a vacation switch. So if we go away for 2 weeks on vacation, I can just shut off the hot water, and it'll never make hot water. It'll save us some energy. Now, basically, just to give an idea of how it works with the hot water tank, this is on your hot water tank. You have this. This is low voltage wiring. It's typically 24 volts. The tank calls for hot water. A relay up here, one of these relay boxes, will then turn on a. I'll show you how that works. It's where is it? Actually, it works through a relay, and it'll turn on the zone for the hot water. This happens to be the zone for the hot water. I've actually put in over here. You can't really see it. I put in a little light. I drilled a hole and put in a little light so I can see when it's getting power and heating up the hot water. So what happens is when this tank gets too cool, the thermostat will close a normally opened switch. Close that. The relay will call the pump for hot water, and the boiler will turn on. This is a Burnham boiler. It's very efficient, and it'll heat up, and it'll send hot water from the boiler through this pipe down into this heat exchanger in the hot water tank, and it'll heat it up. We have a bunch of zones because it's more efficient to have more zones in your house, and that's that. That's the water, the regular water pipes. Now, the other thing is you may find is that these switches can actually be pretty expensive. Still much cheaper than Insteon, but this one's probably $150. This has 2 circuits. This one is probably like about $100. It has 1 circuit, and this is about $300. This also they make. It's a little better. It's what's called a 3R box. It's waterproof. That's how they make this one, or at least water resistant. You can lock it up. It's excellent. Now, what I found is that if you think about it, it's only 4 circuits here, 2 circuits here, and 1 circuit here. It's a total of 7 circuits. I needed to control more than 7 circuits. I needed to control about 10 circuits total. So what I did was I bought on eBay very cheaply this a relay box, and I'll show you what that looks like. This is the relay box. And what a relay box lets you do is, I'll show you. What a relay box lets you do is it lets me add in more circuits onto this relay box. It's pretty cheap. This box cost me about $50. It's an I got it. MR-204/C/R by Air Products and Controls Inc. Okay, so what this lets you do is you can control more circuits the same way to this, and then I can use, I have, for instance, 1 circuit, 2 circuits, 3, 4. I have 1, 2, 3. I have 5 circuits here, and those 5 circuits are controlled by this box. So there are 2 circuits here, and I send power from here. You see, I'm getting the power for these 2 circuits from the power for the timer, because I send the hot over here, and then when I want this to go on, it'll connect this to this, which will send power across here and into this relay box. Now this relay box, and you can see the relays are just switches. So basically you can think of this as almost a manual switch, and when this sends power over, the switch, something like a little, almost like a mouse turns it on, it's the same concept. This gets turned on, and it makes the connection between these 2. So I basically expanded and taken this 2-circuit timer and allowed it to control 5 circuits on a relay box. This I've done a little differently. Because these lights, I want them on most of the time, and I just want them to shut off certain times. I put them on a normally closed switch. So normally this is closed, and the lights go on most of the time. And then I've programmed the timer in reverse. So when I want the lights to go out, I've programmed this to turn on. So I have this turn on, it sends power here, and when it sends power to the relay will take this normally closed switch and open it, and then it shuts off the lights. You could do it in reverse. You could do it and have these normally open and have that close them. That's just your preference. And you can see you can connect to this relay will control 1, 2, 3, 4, 6, 7, 8 or more. 1, 2, 3. I don't know, at least 8 circuits it controls. So it's really pretty good. And what I've used is this 14-3 cable, which is 2 hots, and I've in other words, I've made this into 2 separate timing devices. Even though it's this controls 2, and this controls. I've joined these 2 as 1 on the circuit, and I've connected 4 of them to those 4 circuits to those 2. But basically, this allows you to expand the timer system, which is already pretty good. The thing you should note, though, is that when you're doing this to your house, you should make sure that you're not shutting off all of the important lights, because you want to make sure that if, God forbid, there's a fire or something, you want to make sure that people aren't running around and all the lights are shut off through this timer system. Because unlike Insteon, you can't go and flip the switch on. I mean, it won't help you because the power's shut off at the box. So basically, what you need to make sure is that the hallway lights and the other lights are working and are not subject to this timer system, so that this way, if there's a fire, at least you'll have some lights. But this works very well. The other thing it works well with is, and it's a problem with Insteon. With Insteon, on every switch you have that you're going to connect it to, and this is to my boiler, but it's just an example. Insteon needs access to the hot, the neutral, and a ground. Now, that's not a big deal if it's modern wiring. If it's a new house and you have modern wiring, where the wiring is only 20, 30, 40 years old, it's not a problem. Let me put this down. It's not a problem because typically the way they wire most modern houses is they have the neutrals run to all the lights. That's like the return. And the neutrals are bundled together in the switch in the back. And then the hot wire is what's broken by the switch, and that goes up to power your light. So that's fine. But in this house is 100 years old. and most of the wiring is new, but parts of it are about 60 years old. And the problem with that is 60 years ago or so, they wired things differently. And it's just a good idea to be advised of that, because you might find yourself a little surprised. Back then, they sent the hot wires to all the lights. Everything was hot. All the lights had power to them all the time. What they did was, the neutral coming down went through here and was broken by the switch. So the switch would break the neutral coming down. And I have no idea why they did that 60 years ago, but the philosophy changed and they don't do that anymore. But the problem with that is, if you have that type of old wiring, you're not going to have access to the neutral in the box. Often the neutral doesn't run through the box. They didn't need it there. So the neutral often did not run through the box. You won't always have all the wiring. Or what they did was, as I was saying before, they'd break the neutral, but you wouldn't. The hot wire would be in the wires, and you wouldn't have that in the box. So I think, just to clarify, what I'm saying is, the neutral would come down. The neutral would go through the box. That would be through the wire. That would be broken by the switch. But the hots would go through all the wires. And it's only when when you turned it on that the neutral was allowed to go down into the fuse box and ground out, that the light would go on. So you may find yourself puzzled. In other words, you may not be able to fit your Insteon on, and sometimes the wiring is puzzling. You're not sure how it works. Now, if you have that type of old wiring, the way to test for that is you take the wiring off the top of the switch, and ordinarily that should be dead. If it's new wiring, that's dead, because usually the power comes from the bottom and comes up to the top. So the top wire off the top of the switch going up should be dead. But if you ground it out and you touch it to the ground, and the light goes on, that means that the way this old wiring was is they're breaking the neutral. You got what I'm saying? If it's old wiring, the power goes through the lights, you'll find that the top of this wire at the switch is actually coming back. It's the neutral coming back, and if you touch it, it's making a connection through the ground into the box, and the light lights up. So what I had to do is, I had one area where there were 4 switches, and I wanted to break it up because I wanted to, again, shut off just the dining room light, but I didn't want to shut off the whole lights and the outdoor. I wanted the outdoor light separate. So I found that we ran up with the help of an electrician, I ran up a 14-3 wire. That's in here. It goes in this box, and one of the wires was exactly that. Brought down the neutral from the dining room. I disconnected the dining room to the wiring that was attached there, and I took that and attached a new wire down into here, which is bringing down the neutral, which was the return on the dining room, and the outdoor light was also connected to that. But that was it was crazy. It was that one someone must have done a little bit later, and they did it the modern way of doing things, where they sent power out to the outside, and the neutral was always connected. So I separated that wire and I ran it into here. I ran it then through the timer system, which is this one, the dining room. It's this one, the dining room and the outdoor lights. And by breaking it up into different circuits, I was able to make a separate circuit for the outdoor front light and have that run on just from sunset to sunrise. Okay, it's a little complicated, but it's actually very simple once you play with it, once you figure it out. And in the end, you have an extremely reliable system that's safe, that works beautifully, and you can see, just to show you, you can control this. When you turn it on, that's actually, the lights go on the relays. It's actually shutting off the lights in the house. Because by turning it on, it's turning on the relays, which will disconnect these normally closed switches. I wanted to show you that. But basically, now that it's complete, it's a very reliable system. It's very safe. You're basically just breaking the circuits at the circuit box. And for about $600, you can have a system that gives you the same functionality as an Insteon system, for the most part. All right, it doesn't have the app on your iPod, but what you can do is, if you go to a website like Smarthome, you can buy what's called a web relay or an internet relay, and that does have an app. It's a box. It connects to your router, and you can then control it with an app to turn on and off. It has some normally open connections that you can normally open or close. You can even hook that up to the relay. This relay actually will either open and close with either 120 volts sent to here or 24 volts sent to here. So you could just use that internet relay and give it 24 volts to these switches and turn on and off that. And you can actually have a nice system as well. And you can this way you'd be able to turn on and off lights from anywhere you wanted. But overall, it's very reliable. It's simple. It should last for a very long time. You're not doing all the work in terms of changing all your light switches. You're not going through that expense, and it really runs well. Well, if you'd like to take on this project, I very much encourage it, and I wish you the best. Take care. Be well.